physics question. I saw this question on Reddit and I thought it was a good question, so let's answer it. The question looks like this. I have a battery, a resistor with an ammeter, and then another resistor with a switch. And the question was, what's going to happen to the ammeter reading when the switch is closed? The answer is nothing. It doesn't change. So why doesn't it change? Here we have two things to consider, the loop rule and the junction rule. The loop rule says that if I go around any loop and I add up the voltages, I get to zero. So I have the voltage across the battery, I'm calling that EMF, and then this current, when the switch is open, is minus IR, and that's that. Okay, so now what happens if I close the switch? If I close the switch, what happens to that loop equation? Well, there's still a current coming out of the battery, I, and we'll now call this I. So that equation's still the same because there's no other voltage drops in this loop because there's no resistances. You'd get the same current up here, you actually get double the current, but that current in this branch doesn't change. Now, if you had put an ammeter right there, you would get double the current. Okay, but the current through that branch doesn't change. Also, if you had a real battery with internal resistance, then it wouldn't stay the same. Okay, it would change somehow. But in this case, in the situation they gave, the current would not change when you close that switch. So it's kind of a good question to look at these kind of things.